Nerding and hoarding. Quick and dirty DIY electronics. Welcome to the Nerding and Hoarding Show. If you watched my latest video about the non-inverting amplifier build, you might have learned that it's easy to fail. But if you follow this channel, you already know that. And you might also know that I constantly complain about my layouts because they are laid out like this. The images are like this, which means it implies that you should put the components on the copper side, but actually you're not supposed to do that. And if you do that, it's really hard to solder. So now I finally started to make a method of making a layout with two sides. So it's actually quite simple. Just take, once you have made the front side layout, and by the way, this is in DIY Layout Creator version 4. You can also do it on paper or use other programs. So make a copy of the board and then right click and select edit selection, no, not edit selection, transform selection and mirror horizontally. And what I did then was to make it more clear what it is, take a blank board on top of it, and then you have to set the background grid to 0.05 inch in order to, otherwise it will be like this or that, but now I can make it so like that. And then just make this a little bit transparent to make you see where the holes are, like that. And then you have your copper side and your beige side, I might call it. And then just simply do a, then you can look at the numbers here. So copy components over and just put them in there in the correct places. I'm not really made up my mind exactly about how to do it. The leads going to the panel, but you know, you have to start somewhere. And this is like that. And then these holes right here, if you make holes, they will not be visible here unless you maybe take a small drill and make the hole visible by expanding the actual hole. But I will put it here anyway, just for show. And now, yes, so that's not really visible now, so we can further change the transparency of the overlaying board here. Then this one, I put it here just a little while, and then copy these, and we look at the number here, 5. So on 5 should have 4 like that, and then the board, this one above, and just go on here, paste everything in place. So these are a little bit tricky still for me. I don't exactly know how to do with these, but for now I just maybe do like this, make them maybe really short just to indicate that solder them here. And then you can also make a little text. Yeah, just 1 second. I will finish this before I start to explain the next part. So the last connector is this connector right here. And just paste that in place, in the correct place, and then we can go on to do the next part. So the next part I was thinking about doing like this, just write like this: put all components here, and maybe like right on this side, solder on this side, like that. And then we could even maybe go on to actually do something like this. If we were to, let's see what I'm searching for, just black dot, yes, like that. 1, 2, 3, 4, 5, and then just see how this looks. Maybe we could even do like this, that we push this backwards, send backwards, and then make this a little bit transparent so we will still see, maybe a little bit more. But now this one is also transparent, and it should not be transparent now. So maybe like this could be one method of doing it. And then send all the components. Send backwards, yes, like that. And also on these right here. 1, 2, 3, 4, and then send these back. Send, transform, send backwards. And finally this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. And also these, of course. Like that, like that, like that. And select, transform, send backwards. Yes. So there we go. We actually have a new way of doing things. So I will actually print this now and try to build this again. Hopefully it will work. We got one problem here, because these leads are pushed back. They are behind here now, so we have to send this one back, send back, and this, yes, we should have done it the other way around, I think. First select these and transform, send backward, yes, and then the panel, send it backward. So now we have everything in place. Quite nice, I think. Maybe, yes. So just right, so I will just finish this up and print it, and see you in the build video. Take care now, and don't forget to look at this video because
Nerding and hoarding. Quick and dirty DIY electronics.
Hoarding.
Nerding. Nerding and hoarding. Quick and dirty DIY electronics.
Right, so back with a little update about this, the new way of making double side layout. So when I printed this, I just realized that I had made everything mirror inverted. So that means that everything that is here should be here, and everything here should be there. Good to know, you might say. Yes, so why don't we do like this then? See if that's gonna fly, so to speak. Or if this is not going to fly. Well, we have to see. We just have to see about that now, don't we? Yes, but how do we do this? Yes, we do. Oh my god, how hard can it be? It can be as hard as ever possible, yes. So, okay, so don't mind actually this stuff right here. I will pause and I will come back when I have something that is not totally just crazy. Alright, welcome back. So I now made everything mirrored again. It was actually quite simple. Just select everything and then transform horizontally. Flip horizontally. So, yes. Alright, so print this file, export PDF. Because when I try to print directly from this program, it often doesn't work. So I call this version 3.0. And then file, save and close. And then open it in this application right here. File, open. Where are you? Alright, version 3. And file, print and select real size here, because then you get the correct size, 100%. So there you go, and we switch over to, guess what? Bam! And yes, stop recording that. Yes. So welcome to the workbench. Workbench is where shit happens, right? Do you hear that? That is something burning inside of a circuit. So we just take this and we sort of say that it is failed, and then we try to recycle the components. And, yes, we take this right here. So this is our circuit for our layout now. So, clean out old stuff in with the new stuff, and let's get building. So let's first see what we can salvage from the old failed build. And I can quite quickly see that it is, let's just say we save the panel, because there's nothing wrong with the panel, I think. So let's just snip off here and there, and there. Put this in your recycling bin for electronic components. And turn off that annoying amplifier. So, alright, and I will try to recycle this pin header here just because that gives me a chance to use my most beloved blowtorch. Well, this is not actually my blue blowtorch, this is my black blowtorch, and it's not so powerful. Look here. You see the flame? I hardly see it, I hardly feel it when I touch it. So, yeah, just, fire away until solder starts melting. So now we want solder to melt, but we do not want plastic to melt. Okay, this is sort of just a normal lighter right here. It doesn't have what it takes. So let's just skip that and take a new one. Bam. So if we have this, what components do we need? Yes, we need, let me just tell you, one operational amplifier chip, like that. It's called a 358. You can use 7072, TLO72 if you want. You can use anything you want, doesn't matter. Just remember to update your pinout, because here I have the pinout for the LM. You know what I mean. It's just chips, Who cares about chips names? Alright, so where are we? Yes, we need pin headers. And that is for you who are new to this channel. This is used for getting our input voltage from the Eurorack power supply. If you don't have one of those, you can use two of these and you can get positive and negative voltage from two 9-volt batteries. Just use two of these, or watch my video on how to get plus, minus and ground from a 9-volt battery. Alright, so what do we need? We need a board that is 5x14, and that is a strip board. So because I printed it in exactly 100%, we can see that this is a little bit too small. But on the other hand, if we do like this, I can show you here. If we try to skip this line right here, we just move everything one step to the left, and we skip one of those right here. So let's try to do this on both sides like that, and then we can actually go with this, which is 12 holes wide and 5 holes high, so to speak. Right, so we just count 1, 2, 3, 4, 5 and 6. So on number 6 line, column, whatever you call it, you cut with the knife and then just break it off like that. Beautiful. So now we have to do a little bit of thinking, because it's the new method and I want to be able to see where I have the holes. I mean, if you see here, if you look here, these holes right here, they actually don't go through the whole board, they only go through the copper layer, but I now want them to go through the whole board because I want to be able to see them on the other side of the board. So on this side. So you see, this is this side and that is that side. See, it's color coded. So let's use this instead, because then we can see everything quite nicely like this. Like this. Yes, beautiful. And I am branding channel all the time, which is very important in this time. Alright, I just pause you for a second. So I found my drill bit set right here, and I take the smallest that I have, which is 1.5 millimeters. Be very careful when using such a small drill because you might break it. So therefore I always advise you to just make it stick out as little as possible. Alright, so we are now on this side, and we have also to remember to remove this line here and this line there. So when counting, we count from 1, 2, 3, 4, 5. So drill here. You see, it's not taking out all of the copper, but that's okay for now. And then count from the other side. 1, 2, 3, 4. 1, 2, 3, 4. Drill 3 holes right there. So remember, this is only for sort of indicating where there are holes for the other side. And now take a large drill and just put everything back in place, because it took me some minutes to actually find the drill bits because they were in chaos place number 1. So this one I often use because why, you might wonder? Well, because it's very good for a lot of things, such as this thing right here. So now we're just gonna drill very, very shallowly. Just remove the copper. 1, 2, 3, 4, 5, 6, 7, and then just look closely. Is all the copper gone? Yes, it is. Beautiful. And as you can see here, we are able to see on the other side where we have made holes. So that's a good start, we might say. So what do we do now? Well, we look at this thing right here and we just follow it by inserting components in the same way. So that is in, and we can turn it over and bend the legs just a little bit inwards or outwards if you prefer, but I prefer this right now. I have no idea why, but then the power connector like that. And you can actually bend the legs, but not so easy. I would suggest you bend, if you're gonna bend the ones in the middle, because they are the same. I mean, they are all the ground connectors, so it doesn't matter if they accidentally touch each other. If you accidentally touch power to ground, you will be sorry. So now we can sort of look a little bit. Let's see if we do like this right here. Okay.
Are you able to see this right here? Well, not really. There's something going on here, and I don't know what it is. And now we also want to look at here. Yes, it doesn't want to look here, but if we do maybe like this, then can you please show yourself? Yes, if we look at here, so now we will solder 5 points here. 1, 2, 3, 4, 5. It doesn't matter if we make solder bridge between the 3 in the middle there, and we solder this 8 right here. So first 5 to the left and then 8 to the right. And if you remember the last video, the operational amplifier video, we can compare how easy is it to solder this way, which is the sort of correct way. That was a quotation mark. Right. Yes, but now bear in mind that I'm using a totally different solder that might be totally impossible to solder or totally fine. Oh no, it's like the popcorn solder. Yes, it's definitely popcorn solder. They put like microscopic popcorns in this solder here. But even though we are not having a real solder but popcorn solder, it's still, I would say, about 300% easier to solder this. And when I say 300%, I mean that I'm likely to fail in only a third of the times I try. But that is only a rough estimation, of course. But you know, I love mathematical statistics. So now let's look a little bit on this right here, and let's see if we can sort of cross out the things that are ready, like this, 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 and this. So now we need a little super small jumper right here. You can take just about anything for that. I mean, such as an old resistor leg right here. Yes. And yes, so yes, if we turn it like this, we have to look at here. Okay, so I'm trying to learn this new method right here. So add the little leg in the correct place. Alright, why do they make components so small? Alright, like that. You see, it's in there. When it looks just like that, it's the same. That means it's correct. And then such a small thing will of course want to jump out straight to bend their legs. Yes, so alright. I'm such a videography genius, ain't I? Yes, you are. Yes, you are, Mr. Hoarding. Yes, you are, Mr. Nerding. Right, that went extremely smooth. Extremely smooth. Then just cut off the legs thing, extra leg thing. Alright, and then let's look a little bit more at the thing right here. So this is ready, and we actually did that, which is just connecting all of the 3 grounds. So we just need a ground wire now, a little green ground wire. Okay. And while we are trying to learn how to just fold things back and forth over and look at the 2 different layouts here, I'm going to do that as much as possible. So look here and look here. So we're gonna add the green wire right here on the side, and so remember we removed one line there, and then I'm just going to sort of secure this by weaving it slightly into the pin headers like that, and then when we turn it over we can double check on this. Does it look right to you? It's there. It's hard to see, but it's right there. So, well, I double checked it, it was correct. So it's all written. I really hate this solder right here. Really hate it. Right? It's very smelly also. Probably toxic. Alright, so there you go. The green is done. So what more do we have? So we have exactly four wires here of different colors. That should go here in the 1, 2, 3 holes. So that's quite easy. The hard part is that I don't have all of these exact colors, but that is not very important. It's just that I must have remember to just where I put them, so I don't put them in the wrong place. So I take one of that color, turquoise, with the pink dots, and turquoise again, and then red and blue, which I actually often only use for positive minus voltage. But what can you do when you don't have access to all possible colors in the world? Yes, I must tell you, that is what you must do. So, Danielson, remember to always do like that, and you will become a really good Karate Kid. So just put them right in there from this direction, and remember to sort of make them not fall out before you solder them down. And I will use, let's see here, for the input I use red because it's closest in color to the sort of pink right there, and for the output I use the turquoise without any dots like that. And finally, for the last thing, which I forget what it is, I have to double check. Well, for the negative or for the inverted input, I'm using the turquoise with pink dots, or it's actually purple dots, but who's counting exactly? Color is only relative in the world of computer screens. So then you see here we have 4 points there, and that's our solder points. So let's solder these points, and please focus right there. This camera is not so good, unfortunately, but it is open source. Yes, it is open camera. So solder points 1, 2, 3, and 4, and a little, just a small, but still solder bridge. Well, I removed it very, very handsomely. So then these are ready, and these are ready. So everything is ready actually. The only thing to do now is, yes, we must cut off these. I will zoom out now because we are going to, okay, so we have this one right here, which then represents this right here. So unfortunately, in regards to this one is inverted, but we must not worry too much about that. What we must worry about is that we have to add a resistor right there. You see it? It's right there. Can't you see it? Blind or something? I mean blind. I'm sorry, I shouldn't oppress the blind people, because they are people just like you and me. Alright, so and as I remember, that is supposed to be 20k. Oh no, disastrophe. Can you say disastrophe? It's like a combination of disaster and a catastrophe at the same time. So, okay, I got a 20R here, right here. Are you stoked to see if this is going to work? I can tell you that I am. Oh yeah. So I actually see that I have done maybe something wrong in the previous build of this particular module, which of course can be a reason why it didn't work, because look at here, there are two things going to the same point right there, but I changed this. Yes, I remember in the old one it was like this, so according to this I didn't do anything wrong. Anyway, so now I'm just gonna get this thing ready without too much babbling, so that we can actually try it out, because I am really feeling like, you know, revenge. No, it's not revenge. I mean, in my language, revenge means that you are, first you lost a game, and then in the second game you will win, so then you get revenge. But it's not like you kill the people who killed your parents or something, like it sounds in English. So anyway, green goes to green. Oh, I forgot the branding. I mean, how can I be so stupid? You must remember the name of this channel so that it will become famous, and I will become, I mean, if I wanted to become famous, I would have shown my face, right? But I don't want to be famous in that way. But I want to have a lot of people watching this channel, so maybe, you know, I could spread some knowledge of how to survive in the world as a nerd with depression and anxiety, and how to actually build things in electronics. So you see, there's a dual purpose right there. I mean, seriously. Okay, I am going to try to make this thing a little better. This little thing called my solder iron is not good, so I put it inside of this solder vat. So supposedly it's gonna boil off all of the all of the oxides from the metal that is on this thing right here. I'm not sure if it's working or if it is not working, but you know, it might not hurt when something is really not working. At least it's looking more shiny, except for exactly where it's supposed to be shiny, the point. So anyway, doesn't matter, just get this fucking thing working. Alright, so, but don't do things too quickly, because then the chance of failure increases exponentially. So there's nothing to see here. I mean, if you miss this thing to look at, you know, it's like you miss watching paint dry on the wall and so on, you know, and so forth. I mean, this only actually made it real worse. Okay, so time for some solder maintenance. I mean, solder iron maintenance. I mean, seriously, this is seriously not working at all. So, believe it or not, I actually did my bachelor degree in mechanical engineering exactly on total productive maintenance, which is where you involve everyone in your company in the maintenance of your tools that you are using, and you try to make everyone work there, feel like the tools are their own tools, and you really want to make maintenance on them all the time. I mean, before anything becomes really bad. So alright, so where were we? Yes, so this goes to there, and but what about that one? Yeah, that goes to there. So double check. Yes, in goes to in is red, in goes to positive input, or I mean non-inverting input. So cleaning your workspace is also part of the maintenance. Remember that. But the thing about total productive maintenance is that you should have sort of make everything as easy as possible to do the right thing. To clean, for example, so you put up a lot of notes saying after every this and that, do this and that. But I have not done that because this is my hobby, and I actually left the career of mechanical engineering altogether, and I started to become an artist. Yes, you know, a fine artist. That was 20 years ago, and just you see, I'm a real fine artist, right? I am a poor nerd who is having mental health issues. So there you go. That's a success story for you. Alright, so I actually believe it is ready, except for some fine adjustments, such as gluing this to maybe here and soldering the last point here. So let's heat up the glue gun and get some signals going that we can try to amplify. And let's see what kind of trouble we can make with this thing right here. Anyway, if I'm just gonna say a quick note about the system here, I would say it is working very good, I think. So I will try to do that in every of my layout from now on. And you know, but you know, it's yeah, actually it's great. I would say it's great, but I cannot guarantee that this shit is not gonna fuck up, you know. Or I'm sorry I said the F word for all of you who are sensitive to such words. I will just add a little thing here called an indicator of what is the red side. I don't even actually have to solder it, but I can do that just because I can. It takes 20 seconds, but of course I might fuck up something that is really important. Right, so it's probably gonna work, but you know, I'm giving it sort of 70-30. 70 towards it's gonna work and 30 towards it's gonna fail. So, do you want to stop the video, pause the video now and write in the comments field what you think is the percentage chance of this build actually succeeding or failing? And also you might want to write why. Specifically if you spotted something that is a very typical failure thing that I did. So now let's zoom out a little bit like this, turn it over, and just test the input. This is the input, this is the amplifier, so just test it. No sound. Yes. Oh, that's loud. So just test it. So we have a real nasty sound that we are going to mess with now. So we can shrink it and we can amplify it, but we can't really amplify it until the maximum. So why is that? I don't know. I will pause and I will set up the oscilloscope and we can look at incoming signals. No, I just realized that I didn't put any electricity in here, so that's why we couldn't amplify anything. So let's look at it again. Now we have hopefully incoming voltage, and guess what? It's not working at all. So that's fun to know, which for all of you who voted failure. Yes, but I will test it anyway. Test it like this, right here. Just test, do we have any electricity coming into? Yes, see, power supply is on. And incoming voltage is coming in. Bam, that's right there. And output is there and input is there. So drum roll, it's actually there's a little sound coming now, super small sound right here, which then just decreases. Then there's another noise here. Well, double check. Alright, let's just try a little different sound, because that sounds so horrible. That also sounds so horrible. Alright. So just stay with me. So we have that sort of dark humming sound. So it's actually seemed to work. So here we have the minimum and the maximum. So it's as I said, it's probably inverted right there, but who cares? I mean, just write minus on that side and a plus on the other side, you know, so we know. And now I am going to try to look, I'm going to try to take the camera towards the oscilloscope like this, but now then it's falling out. Whoa, whoa, whoa. So, as I told you 100 times, every time I touch the camera it stops filming. I really don't want it to do that. So, just put some random stuff behind. Yeah, there you go. There you go. Okay, so it's sort of working now. Okay, so there you go. Now it is sort of working, and I am turning on the oscilloscope. I'm turning off the light here. Maybe that's even worse, I don't know. And then I have to change the connectors to the connectors that go to the oscilloscope right here. And probably I should also change the incoming signal to another signal, but let's just start to see if we can find this signal right here. Whoa, that's interesting. Okay, so you think you know something, you know, but then guess what, you don't know a thing. Okay, so this is probably the best we're gonna get. This is a square wave of a certain value, and when I turn, okay, now I turn all the way to the left, and that is increasing the amplitude, so I'm just gonna try to zoom here. Alright, this is not the best of, yes, okay, we do like this. So now it's all the way to the left, and now it's all the way to the right, so I can actually double the size of it, which is probably good if the incoming signal is about 6. So let's try it with a slightly smaller incoming signal, if you know what I mean. Oh, I'm so sorry about that. I'm gonna fix it, and I'm going to make the video more interesting. Like, whoa, sorry about that also. I'm really messing it up today. But doesn't that look good to you? Alright, so let's just zoom a little bit like this, and we take to get the maximum. Okay, we have the maximum right here, and what we want to do is just, so now we have a sort of a good setting for input signals right here. So let's take an incoming signal that is sort of triangle wave, and that we also take through a just remember, now we are maximum zooming it. So now we are what's it called, we are not amplifying it too much. Okay, so you see, it's a triangle wave. I will try to change something here. I'm not exactly certain about what it is, but okay, if you look at it now, so this is what you can do with this. You can amplify it, and we are amplifying it until it sort of hits the roof, and it hits the ceiling as well, or I mean the floor. And then it turns into a square wave, and now it's really small, so we can actually, and if I decrease it even more, so now it's hardly visible here on this scale, so we might have to zoom in. How do we do that? Yeah, so now we have zoomed in more than we just had, and I'm sorry for that, I fucked up. did you hurt yourself? Alright, so now I'm turning the amplification up to maximum, or slowly. So now we are at 50%, we are at 70, 80, 90, 100. And you see the last part there, it's quite hard to actually control, but you know, you might not want to use that part then. And here we are at the other scale, and we maximum amplification and 50% application. And so it's not really that you're able to actually control this area right here, but you can have it like this, use it as a square wave shaper. And if we have this now, the incoming signal is about 5 volts, and then we can actually control a little bit better, except for the very last part here, because that's where it goes to actually to 0, and the operational amplifier actually turns into a comparator instead of an amplifier, but that's for another video. So with this little demonstration, I will just thank you for watching, and I will do something here that just looks cool, but I have no idea what it is. Yeah. Because, you know, we must have cool stuff to look at as well, don't you know? We can't just listen all the time, we have to look as well, you know? Let's just take the sort of this like there. Just insert the thing like there.
nerding and hoarding. Quick and dirty DIY electronics.